This is the second lesson in Unit 1 of Pre-Cal. We're going to review linear inequalities and absolute value. We just did a section on equations, linear equations, or equations of various sorts. And so you need to go back and we'll review a little bit about these inequalities. Now, when both sides of an inequality are multiplied or divided by a negative number, you have to remember that you have to reverse the direction of the inequality, or of the symbol of the inequality. You have to switch the sign from greater than to less than, or vice versa, to less than or greater than, only when you multiply or divide by a negative number. Okay, that's a big only, and you have to remember that. So we'll go through and do a few examples. We have 5x minus 7 is greater than 3x plus 9. Subtracting 3x from both sides, you'll have 2x over here. And adding 7 to both sides, then that's greater than 16. Dividing by a positive 2, we end up with x is greater than 8. Now, if you're going to set that on a number line, always put your 0 in there, and then you can set some sort of a scale, 2, 4, 6, 8 if you want to. Counting by 2s, this is 4, this is 8. You know, if you want to go on 10, 12, you can. Now remember, if it's greater than 8, it doesn't include 8. There's no line under here to tell me it's greater than or equal to 8. So that means it doesn't include 8, so you use an open circle for that. And then you shade in the greater than, the part of the number line that shows greater than. Some people like to put their open circle here and shade above the line. You can do that if you want to. I tend to shade right on the number line. Alright, now we're going to use that same skill that we learned in the last lesson about multiplying by the least common denominator, in this case 2, so that we don't work with a fraction. We can get rid of that fraction. It makes it a little bit easier when we're working with equations. So we're going to multiply 2 times each of these pieces. So we can just put 2 times that. We'll distribute the 2, and on this side we'll distribute a 2. Alright, so we end up here with 2 times 1 is 2, minus 3x, because 2 times 3 halves would be 6 over 2, or 3, or you can think of the 2's canceling out. 3x, and we still have our symbol greater than or equal to 2x minus 8. Okay. Now we have, I'm going to purposefully make a negative x. So I'm going to subtract 2x from both sides, and that will give me 2 minus, that would be 5x, negative 5x over here. And I'm going to subtract 2 from both sides, so that's going to be negative 5x is greater than negative 8 minus 2, or negative 10. Now we're going to divide by negative 5. And when we divide by a negative, remember, or you could say you multiply by negative 1/5, either way, we divided by a negative, so that means this sign has to be turned around. And so we have positive 1x is less than or equal to positive 2. And that's going to be our final answer on that problem. So we have mark our 0. 1, 2. This is 2. We need to write what it is. This one is a solid dot. Now I'll put it up here. Because it's less than or equal to, that means it includes the 2. And we draw less than, you think of left maybe, it's sometimes helpful. Both start with L, and go to the left and shade along the number line what's less than 2, and the solid dot indicates it's also equal to 2. Okay, let's look at a double. We've got an inequality. We've got two inequalities here. Well, you can set it up as two different equations, or you can just do the same thing to both sides. We want to add 1 to both sides, so negative 3 plus 1 is negative 2, is less than or equal to 6x, and then is less than 3 plus 1, or 4. Now we need to divide everything by 6, so we have just 1x. So negative 2, we can show that, dividing everything by 6. This is going to be negative 1/3, and it's a positive 6, so we don't, even though this is a negative answer, the sign stays the same because the number we divided by was a positive 6. And that's a 1x, and we need to reduce this fraction, which will be 2/3. Okay, so we have negative 1/3 is less than or equal to x, which is less than or equal to 2/3. So here's our 0. If this is 1, then negative 1/3 is about right there. Okay. If this is a positive 1, then positive 2/3 would be right about there. One of them needs to be a solid dot because if you notice this one, this is going to be a solid dot because it's less than or equal to. The 2/3 is going to be an open circle because it's, and I'm going to make that a little more apparent that it's open. I almost filled it in by accident. So let me go back and make that look like it's supposed to. This is a 0, this is 1, and our 2/3 is going to be an open circle right here. Okay, and x is between negative 1/3 and positive 2/3, so we shade in between the two dots. And that's our solution set. Alright, now let's look at number 4. We again have a fraction, so we want to multiply everything through by 2. Now you're going to notice though, so we're going to multiply everything by 2, but you notice that this 3 minus x is in the numerator. All of that is over the 2. So you're going to when you multiply by 2, that's going to be left uncancelled. So 2 times negative 1 is negative 2. These 2's will cancel, so we have less than, and then we have 3 minus x. And that's less than or equal to 2. Alright, now we want to do everything. We're going to add or subtract. We're going to leave our x, our variable, by itself in the middle. So we're going to subtract 3 on each side of the inequality. So this becomes negative 5 is less than negative x, which is less than or equal to negative 1. Now we have a negative x, we need a positive x, so we're going to divide everything by negative 1. And so what we end up with, and I'm going to go down here because I'm running out of room and I don't want to crowd my number line too much, so I'm going to go down here with my math. That becomes 5, positive 5. Switching the sign, remember, because I divided by negative 1, is greater than x, and I have to switch this sign again because I divided by negative 1, so that's greater than 1. Now we really need to put this in order. So we're not going to leave it like this. We're going to put our 1, our lowest number, first on the left. So we're going to rewrite this. 1 is less than or equal to x, which is less than 5. Because we want to put it in number line order. The lowest number first and the highest number second. So now let's put it on our number line. Here's our 0. And we need to locate a 1, space them pretty evenly, 2, 3, 4, and here's a 5. So here's a 1, and here's our 5. What kind of circle do you need on the 1? It's less than or equal to x, so we need a closed circle here. And we need an open circle on our 5. And it is x is between 1 and 5, so we're going to draw that line between them. Alright, now on our next page, let's go to our mouse. And when I do the mouse, all this is going to disappear, so don't panic. We're going to go to our next page of our lesson. Okay. We want to solve these absolute value equations. Now remember, absolute value is the distance from 0. It's never negative. That looks like an R, but it's a V. Absolute value is the distance, okay, from 0. Alrighty. So we have two equations. We're going to write one just like it is. Remember, you always set this up. We have 5x minus 3 is equal to 17. And my next equation, the other equation I'm going to work with, is 5x minus 3 equals negative 17. And solve for x on both of them. So we're going to add 3, so 5x is equal to 20. And divide by 5, x is equal to 4. Here, subtracting 3, or adding 3 to both sides, but now we had a negative 17, so 5x is equal to negative 14. And so when I divide by 5, x is equal to negative 14 fifths, and we cannot reduce that fraction anymore. So 14 is 2 4/5. So if I'm locating, okay, we have 1, 2, 3, here's 4, okay, 1, 2, 3, 2 4/5 is right about in here, so that's negative 14 fifths, okay, and it's just two dots. It's not an inequality. You notice x is equal to negative 14 fifths right there, and x is equal to 4. Those are the two values that will solve that absolute value equation. It is not an inequality. In this case, it's an equals. It's an equation. So it's just 2 points on the line. When we go to this little bit below, yes, it is an inequality. All right, let's do number 6. Same exact thing. We set up two equations. 7 minus 2x is equal to negative 5. And then we have 7 minus 2x is equal to 5, and I put 7x, so I need to erase that. Okay. Now one thing we should have done here is to double check to make sure. First of all, we have to notice, we wrote this down. Now something's wrong with this picture. What's wrong with this picture? An absolute value cannot be negative. Okay, so it cannot be negative. It's a distance, it's never negative. So what that means is this is not possible. So even though you get started and write this down, I could solve this and possibly come up with some solutions to this equation, but because this absolute value, there's no way any absolute value is negative. So the answer to this is an empty set. This is not possible. And that's something you might just have to recognize. You know, it's not, it could be that it's just going to catch you. You may not be able to recognize it, but you're going to have to try. All right, on these absolute value inequalities, you're going to, these are inequalities, that's a key. So you're going to have a less than or greater than sign. And so one thing you need to notice, if it's less than A, then you have a conjunction. It's and. Your answer is going to be and. It's one way to look at it. It's a conjunction. Okay. And the number, the x is between two numbers. The x is between two numbers. Okay. If you have greater than, it's or. Okay, your answers, you think of or. It's a disjunction. And I wish my pen was writing a little better, but it's not. It's a disjunction. Okay, and it moves outside. The arrows point in either direction. So I'm going to write the word outside. The arrows point in either direction. Okay. So the way you're going to set this up, if you can remember these two forms, that makes it easier. You know with the less than that you can set it up like this. You have negative 6 is less than x plus 3, which is less than 6. And then you solve, subtracting 3 from both sides, you get negative 9 is less than x, which is less than 3. And that's your answer. So you have 0 here, 3 here, negative 9 maybe way down here. Open circles on both because there's not less than or equal to, it's less than. And you draw the line between the two. Now what if you didn't remember? What you have to remember, the important thing you need to remember for solving these, is when you set up your negative equation, you need to turn the sign around because that's what happens. Remember when you have the negative. So if I had x plus 3 is less than 6, that one you set up just as it is. And you would find that x is less than 3, which you see on this one, x is less than 3. We've drawn that. But when I set up my second equation, x plus 3 and negative 6, you have to turn your sign around because it's like dividing by negative 1. So this would be greater than, and then when I solve it, I have x is greater than negative 9 when I subtract 3 from both sides, and we can see x is greater than negative 9. So it's greater than negative 9 and less than 3. So you can solve it this way too by setting up two equations, but you have to remember to flip the sign when you put that negative answer on there just before you solve it. And same thing when you're setting these up, because these you do set up as two different equations, and you notice what they did here, they flipped the sign on you. They showed, the notes show you how to set these up, but that's why. Okay, so we have x plus 3 is greater than or equal to 6, leave one just as it is, and then the other one is the negative where you switch the sign. X plus 3 is less than or equal to negative 6. Subtracting 3 from both sides, x is greater than or equal to 3. And subtracting 3, x is less than or equal to negative 9. So this is an or statement. This is and. It's between these two. In this one you have your 0, and your 3 is up here. Negative 9 way down here. Alright. Less than or equal to, I have my circle that I color in because it's less than or equal to, and it's going outside, it's going to the left. They're not going to join on the greater than when your initial absolute value inequality is greater than. And on this one you're going to go x is greater than 3, so you go out this way. Okay. So that is your absolute value and linear inequalities and some absolute value equalities for lesson 1-2.